Live from HumanX in San Francisco, the Frontier series brings to you the builders working at the frontier of AI to talk about emerging technologies in the field. My name is Viviana Márquez, Developer Relations Engineer at Prolific, and today I'm here with Dr. Dakuo Wang. Dakuo, welcome and thank you so much for joining us.
Thank you so much for inviting me here.
Yeah, of course. So why don't we start by introducing yourself to our audience. Tell us who you are and what are you working on.
Sure. Hello everyone, really glad to be here. My name is Dakuo Wang. I'm currently Associate Professor at Northeastern University in the Computer Science Department and also the Design Department. I'm also a visiting Associate Professor at the Stanford University, and I'm based in Palo Alto, so I'm also providing various consulting services to big and small IT companies here who are interested in agentic AI systems. Really
awesome.
Nice.
I'm really excited to talk about your research today. Mm-hmm. More specifically, I would love if we could talk about one of your recent papers. I'm going to read the title. It's called LLM Agent Meets Agentic AI. Can LLM agents simulate customers to evaluate agentic AI-based shopping assistants? So I will want us for us in this episode to talk about digital twins. Mm-hmm. How can we use digital twins as agents as a judge? Mm-hmm. So let's start the conversation by setting the stage. Maybe let's take one step back and talk about AI evil. So why nowadays is evaluating AI so hard? Because back in the day, you could just compute one number and yes, compare models and select the model, but now it's quite more challenging. So why is that?
Exactly. So I think nowadays, everyone would agree, no matter that they like it or not, that today's system, IT system, AI system, computer science system development is very different than, let's say, 2 years ago. So nowadays, every company or even like individual developers, they can design and ship system in a much faster space. In the past, if you think about a Windows system or like Mac OS system, maybe in a year you may have like a 4 or 5 major release. But nowadays with an AI-based or AI native system, you may have like a 5-10 new features per day. If you look at the Open Cloud, the Cloud Bot, like nowadays very popular, everyone using, right? They have 1.5 million lines of code, and every day they have maybe 20, 30 new features delivering. Because of this fast and rapid kind of like speed of delivering new features, it's very hard or almost impossible to run the original or established kind of like a unit testing, like usability testing, system testing, kind of like a classic evaluation approaches that we have been learned and taught at school. So now you have to have a new way of evaluating this system at a much faster speed as well. What if, let's say, tomorrow Meta or some of these big tech companies want to deliver like 1,000 new features, test and deliver 1,000 new features? Which one should be online? Which one should be killed? We have to find a new evaluation solution. So that's why AI-based evaluation or agentic-based evaluation is something that all the companies and the research labs are looking into. And I think that's the only promising solution that we are facing in this new era of AI and agentic stuff.
Yeah, exactly. Like you mentioned, by the time we're evaluating version 1, then the system is already in version 3, version 4. So it's quite challenging to keep up. Also because the nature of the problems that we're working on nowadays are not deterministic. No. So even if the user asks exactly the same question, they're going to get a different response. So yes, how do you integrate everything?
Yes.
And also the answers might be subjective. So who says whether it's right or wrong?
Exactly. So I think what we were mostly discussing is the speed of the new AI or computer systems delivery, right? So the speed is very fast. That's why we need this agentic evaluation stuff. But also on top of that, you're absolutely right. Nowadays the systems are like more tailored and personalized towards individual companies or organizations or individual human beings' needs, right? You don't really have lots of prior knowledge about these individual organizations or individual users. But if you just ship those features fast enough and then gather the feedback, gather the usage log data after the system being delivered, and then you can keep reusing those data, and then that's the flywheel basically of improving your system to a much faster speed. So that's the second reason, right? Systems are being more individualized and customized towards the different domains. I think maybe I want to add that there's a third reason why we need these things, because AI, as you said, it's very new, and no one knows what would be an agentic social media platform, for example. Everyone knows how to design Twitter, right? What's good or bad about Facebook, but no one knows what's an agentic AI system should be look like or not look like, right? So now what can we do? We have to try to ship as many features as fast as possible, and then see what the market is really looking into those features, how they respond to it, and then we iterate this very fast delivery and a fast feedback gathering loop. I think that's also one unique feature or challenge of today's AI-based system development era.
Yeah, evaluating AI systems is quite important because if you can't measure it, you can't improve it.
Yeah.
And one thing I found fascinating about your paper is that usually people are thinking about outcomes, but I like to think of this analogy with restaurants. You could go to two restaurants, get two fabulous hamburgers, but if in the first restaurant the service was better, the waiters were friendly, the service was fast, and then in the second restaurant the waiters were rude and the service took forever, of course you're going to prefer the first restaurant, even though the outcome is exactly the same, the most awesome hamburger.
Exactly.
So it's the same thing with AI. You can achieve the same outcome, but you should be evaluating the experience as well.
Yes, exactly. So on the internet, I think the exciting thing is that our internet footprint are already abundant, right? If you think about you go into, let's use the restaurant, order, online order kind of example that you just hinted, right? If I go to a restaurant, I eventually order the burger, but along the process, I may choose with onion, without onion, right? A very spicy or mild spicy. I may eventually choose mild spicy, but along the way, I actually clicked the medium spicy because at that moment, I was actually thinking and debating, right? These things are currently not being utilized by any of today's traditional computer science system because the traditional recommender system, they are mostly focusing on the final outcome, right? You order the burger is a mild spicy, that tells me you are interested in mild spicy. But if you actually utilize all these digital footprint, you can see this customer, me, may be interested in mild spicy and medium spicy, right? And in the future, right, we may not only recommend a restaurant that has this mild spicy or non-spicy food, but also we can recommend something else. So these kind of information, very personalized, very human thinking, reasoning-oriented information and data already exist, but were primarily ignored. If you think about today, the most advanced AI systems, agentic tool-use systems, right? Why DeepSeek, Q1, today's GPT 5.3, 5.4, or Opus, Cloud Opus are super good because during the training, they're very much focused on reinforcement learning to try to predict or generate what the next turn human would think or the model should think instead of just that action, what the model should do. Thinking is the most important, it's the most powerful reward in nowadays model training. So in the real world, we have those human thinking traces. It's just not organized, not utilized. But we have a huge opportunity here, and that's why I'm very optimistic about the next year or so. I think every one of us will have a much more powerful agentic AI-based maybe assistant, maybe tool, maybe features on your existing apps, right? But our life and the study and the work will become much more convenient thanks to this technology.
Yeah, definitely. I love how you extended the analogy because it's not the same. The perfect hamburger to me is not the same perfect hamburger to you. Maybe
Exactly.
I like it less spicy and you like it more spicy. So it's the same thing with AI. It's not only about the right outcome, but the right outcome for that specific person. And you need
Yes.
to have a way to evaluate that. And that's why I thought your paper was very important because it shows a path to conduct those evaluations. So I think this is a good way to introduce now the topic of digital twins. Maybe for our audience that has never heard of the concept of digital twins, can you tell us a little bit more about them?
Yes, that's a great question. So I think all the customers nowadays are familiar with ChatGPT or large language model, right? So these are just models that you give it a text-based prompt or image-based prompt. It gives you one response, right? And that response can be an image or can be a text-based. So that's a single turn use of a large language model. But now let's talk about ARM-based agents, right? So this has been a popular idea since maybe 18 months ago, right? What people have been figured out is that these large language models are not only capable of generating that single turn response as a text or image, but also they can mimic human behaviors. Like, if you gave the large language model enough contextual information. So these contextual information, including things like a persona. You tell the agent, like, imagine you are Michael and you are 35 years old, a software engineer living in San Francisco downtown. In your spare time, you like to do A and B, right? Now tell me, how are you going to do with this current situation? For example, like, there's are two job opportunities. Which one would you want to take, right? There are like, a piece of code, how would you like to decode or fix or debug the code? So these kind of prompt, once you give the ARM, they behave very much like a human. They can tell you not only like, what is a text output, but also how they respond, how they think, how they behave. So this is an ARM agent. Within the ARM agent context, the technology has primarily divided into two big subsets. One set is called agentic tools. So these are things like, if you think about open cloud, right, or cloud code. So these are the agentic AI tools where it can perform a certain task given maybe code developer or code tester's persona, and then perform those tasks in multiple steps. So not a single step, but multiple steps. Along those steps, it can also use various third-party tools, like it can use Figma MCP tool to debug the UI or improve the UI, right? So that's the agentic AI, one of the two ARM agent usage. The second one is what we call the digital twin agent. So this digital twin agent, their idea is very, or their motivation goal is very different from the first batch of agentic AI system. Agentic AI is trying to finish a task as fast as possible and aiming for a higher accuracy or completion rate. But the digital twin, on the other hand, is not optimizing for finishing the task or completing a task faster using less tools or using less steps, but rather digital twins should be behaving very much like a real human being. You have a particular target human, let's say maybe me, Dakuo, right? If you want to build a digital twin of Dakuo, then that digital twin may behave a similar, reason and behaves very similar on a particular task, let's say online shopping, right? I go to Amazon.com or some of those like online shopping platforms. Even if I decided I want to buy Adidas shoes, right, running shoes, but I may still want to check out the Nike shoes first to see what's the like a trending design and the topic and technology that Nike, and then this kind of practice or these multiple steps is gathering information so that I can internally justify why I want to buy Adidas shoes, right? But to an agentic AI system that I was referring to as the first style of the system, these Nike shoes browsing activity are considered as a wasted step. They should be eliminated. They should be optimized to remove those steps because they are not contributing to that final outcome, right? But if you are simulating or your goal is to building a digital twin system, those systems, those steps are actually the very necessary step your system should try to mimic and behave, because those steps, even though they're not contributing to the final outcome, but they are contributing to humans' confidence. They are contributing to some decision-making power that the humans' cognitive science or cognitive system must need, right? You throw that final decision to them, people would not listen to you. They go, why does AI give me this? What if there are other better solutions or better outcomes I should be also looking at? So I think that's the main difference of the digital twin agents and the agentic AI system. But after all, they are just agentic applications of utilizing AI.
Yeah, I think that's a great overview of your paper, because then you're using the digital twins to evaluate agentic systems like a chatbot, for example, the shopping chatbot in
Yes.
Amazon.
Yes.
And I think that's also a good clarification that a digital twin is just an LLM prompted to behave like a specific human.
Like a specific human. Yes.
Maybe if you could tell us more about the type of questions that you get out of the humans to be able to prompt the LLM.
Yes, exactly. So that's what I was saying, like you need to utilize the prompt space or the context space so that you can give a model enough information so that it knows human, like your target human, and then it can maybe behave very similar to that human being in a particular scenario, right? So in this scenario we chose is online shopping. Why? Because online shopping is an area that you can imagine that human have left lots of digital footprints on your browser, right? You click on certain buttons, you type in a certain query into that search box, and then you scroll down to read the other customers' review. You click backward like a keyboard so that you go back to a previous page or next page to browse that product recommended list, right? These are all useful information, useful data that we can use to prompt system to be more like a human digital twin. In addition to these, right, there are also various kind of information that are not recorded on the keyboard about this human being. For example, your personality, right? There are these big five personality. There's that MBTI personality questionnaire, right? We use those kind of personality surveys to gather more information about this particular human individual, right? I should say, like, we recruited 100 of such human individuals using Prolific because Prolific is way powerful than many other like crowdsourcing systems in recruiting the very specific target user population, because we want to say, we want to have 50% of male, 50% of female. We want to have a nice distribution of the education level. Some maybe high schoolers, some maybe like college, some maybe a second degree, right? So using Prolific, we have 100 of these people. We have their basic demographic information, and then we have those the psychometrics. On top of that, we also ask each of them to write a small paragraph, maybe 2-3 sentences, to describe who you are, right? What do you do? But hiding those sensitive information, like say, what's their real name, or where do they actually live, right? So we later use software to do data post-processing to remove those sensitive PII information. And then this would be the information, the contextual information we provide to the agent. So this technique is not invented by us, right? There are lots of researchers from social computing, from other computer science department, business school, that are already using and tailoring this kind of method. How do you better or best describe a human being so that the LM can think and behave like you in certain limited like context or task scenarios. If you are interested, or if audience are interested, you should read some papers released by Stanford University or by MIT Sloan School. There are very interesting findings.
Yeah, we'll put it in the description, the paper, so people can read about it. One thing that was a good learning for me is that if I had attempted to create a digital twin, I would have just start by describing the person. So for example, if it was my digital twin, I would have described how old I am, where do I live, what languages do I speak, and so on.
Exactly.
But I also found it interesting that you also use behavioral data. So how were these people actually behaving once they were shopping on
Yes.
Amazon Rufus?
Yes.
So then you could create the digital twin based on the demographic data, but also on the behavioral data.
Exactly.
So maybe my follow-up question is going to be, once you had those 40 people that you recruited using Prolific, and then you have their digital twins, how do you compare them?
Yes, so that's a very good question. So you can ask, basically after that, you design a very traditional usability testing kind of like a study, right? You define a fixed amount of time, let's say 30 minutes. You gave this a human a certain number of tasks. In our study, we gave them each of them 2 tasks. One task is say like you need to buy a new monitor for your home-based office, right? Desk, and you have a $250 budget, right? And then just go to Amazon webpage to start your typical like a shopping practice, and then by the end you just need to add that monitor to your shopping cart. We ask each of our human subject during this 30 minutes user study session to install a small browser plugin, so that the small user browser plugin on their Chrome browser will keep track of each of their action on the keyboard and the mouse, and also keep recording their screen, how the screen look like, the Amazon web page look like, right? That web page view is basically what we call the observation space for the ARM agents. And the user's action, like their click, their keyboard stroke, right? So those kind of things is what we call the action. On top of that, very useful and very importantly, I don't think any other people have done that. We are trying to mimic the user studies think aloud research method, which is during a process, like while as a user researcher, you are observing your human subject performing a task. Sometimes you may be wondering, why are they doing that? Why do they click on that Adidas, why do they like click on that $400 like a monitor, even though they were instructed to only have $250 kind of budget, right? So you may want to ask them, and they may tell you what they think a lot. So that's called the think a lot. In this study, we designed our small plugin to randomly pop up some questions on their screen. Say, oh, we noticed that you clicked on that $400 monitor product on the previous page. Can you use a few words, tell us what did you do? Why did you do that? So that the reasoning piece is also what we are collecting. At the end of that session, basically we have a user's persona, right? So describing that person. We have their action trace. That's a trajectory of clicks and keyboard action. We have a trace of very sparse but very valuable reasoning, right? Why did they do that? What are they thinking? What they want to do next step, right? And then we have their observation. When they are doing that action, thinking about that, what are they seeing on the screen? So these 4 dimensions construct a very, very valuable and important data set. Not only like if you want to build agents as digital twins for that individual, but also very valuable if you simply want to train an agent in the future that can behave like a human, like your shopping assistant in the future, right? Those data set would be critical for advancing those AI models. So in this particular paper, we are just basically applying this research methodology, but in a very niche and narrow domain, which is agentic AI shopping assistant that Amazon recently released. So if you go to the Amazon webpage, there's a Rufus shopping assistant. The idea is that you can use conversation to interact with this Amazon Rufus agent, and it can recommend products based on your preference and make a suggestion. And then you can click on those products that they recommended and finish your purchase simultaneously. Right? That's basically Amazon's experiment of trying to switch their GUI, like graphical user interface based interaction, to a conversational based interaction in this agentic era. You see that in ChatGPT shopping, you see that in Perplexity shopping, every like conversational AI companies are trying to do that. Using our system, right? We are basically trying to help these companies or these developers of such a system to answer the most valuable question, right? No one knows how to design a conversational shopping agent system. What are the features should be included? How big the button should be? How many products they should recommend? But how can you gather those feedback if you don't want to mess up your valuable user populations, like customer experience, right? If you test some bad design, it may be like leaving some bad marks on those people. Then may decide not to use your system in the next half a year, right? Lose people's face is very easy, right? So using our digital twin agent, we can actually provide the designers and developers of such agentic AI system a very powerful tool so that they can gather some feedback from those large-scale digital twin usability testing, so that they can eliminate those very obvious bugs or user experience flaws even before they see actual user. And after that, then the winner features or the designs can then actually go online and then use the real-world A/B testing or the live traffic so that they can further iterate.
Right, and I think this just goes back to the topic of scalability and how things are changing so quickly.
Exactly.
Because traditionally, you have to recruit people, plan ahead.
Yes.
And then if you do that nowadays, where you're deploying so many features every single day,
yes,
by the time you're evaluating version 1, you're already in version 3.
Exactly.
So I think this is super important. I was thinking about the exercise with the budget, where you gave the participants a budget.
Mm-hmm.
So, for example, you have $200 to buy a jacket, and they were clicking on the $400 jacket.
Yep.
I could see why, if I'm shopping and I have a budget, I would still look at the thing that I maybe like, or maybe I aspire to have one day. I'm curious if the digital twins ever clicked on more expensive thing, or they were more disciplined.
That's a very, very good question. That's actually spot on today's limitation of these agents or the digital twin system. They are so submissive to human commands. They don't do those kind of like exploratory things. If you tell them look, generate or edit a paper paragraph for me, they'll just do that. That they don't do like a one step ahead. If you ask them to explore the monitor options under 255 and give me a solution, they tend to fulfill your requirement or your order as fast as they can, and definitely not violating any of your rules. But that's actually wrong. Not wrong, but that's not how a human being would do, right? Humans are really curious, right? You would try to bend the wheels or bend the rules to see, oh, what if I do this? What if I do that, right? You tell me that you want to buy Nike, but what if there's a great reviewed shoes about Adidas? Maybe human want to take a look. Maybe not this time, but in the future, right? Human beings are so fascinating creatures. We're not like machines. We're not like these kind of today's agent. So I would say if you want those agents to be high fidelity digital twins, that's something that the fundamental technology, the bare bone kind of model need to advance toward that direction. Luckily, nowadays we have seen many of advances in this direction, because if you look at today's cloud code kind of multi-agent system, if you look at the open cloud, this kind of a personal assistant multi-agent system, right? They are using something called skill, or skill.md or soul, or a memory. They're using this kind of a fuzzy a space to tell the agent what the user prefer to do, but not really as a hard boundaries or criteria to guide the agents. You must not do that, or you must not do that. So I think with this like a multi-agent system, with the memory, with the evolving layer, with these kind of like skills and rules, we are definitely going to reach there. All right, but it's just not there yet.
So you were mentioning that to be able to compare the digital twins to the humans, you were measuring 4 things. So one was whether they purchased the product or not. The second one was whether it was the same product. The other one was more on the behavior, how many turns the conversation had, what did they click.
Yeah.
And the fourth one is how they evaluated the whole experience. So I'm curious to see, where did the digital twins match the human experience versus where did the agents just completely turn?
So using the technical terms of these kind of user studies, right? So we measure qualitative metrics, like what you said, like humans reported like experience while interacting with the system. So that's the qualitative metric, as well as quantitative metrics, things like whether they purchase at the end, right? Or how many products they browse during the session, right? So what I can say is nowadays, right? So those post-session evaluation, like qualitative matrices and the quantitative matrices aligned actually quite well, to my surprise. So there are certain things like, the real human customers, they feel like, the agent system is useful, like maybe 9 out of 10 they made the purchase. And I think in our like a digital twin experiment, also about the same percentage of the digital twins made the final purchase. So if you only look at the by the end of the session, right, you see some similarity, which is quite promising and encouraging to us. However, what we see that these people, like the human and their digital twin differ the most are the process, right? So human beings tend to be more like exploratory, right? They want to check out those different options. Right? They maybe misclick on some buttons and then like go back to their previous click. But agents are very accurate, right? So they never misclick on anything. They just, I guess maybe it's the design of our system, or maybe it's the model, right? The model that we were using back then, or like a cloud Opus model and a ChatGPT model. They were instructed, or they're trained and instructed to be good at this kind of like a precise actions in the past, and shortest path into the future to get something done. If you look at the most recent released models, those models are actually baked with the capability of exploring what are the tools available to them, what the tools they may be using. Even if they don't know the answer, they may be using a web search tool to find the answer, right? If they don't know how to calculate a number, like minus or multiply, they can use a calculator tool. So the state-of-art models are already much more powerful than the model that we were using when we were conducting the study early last year, 2025. So I'm very optimistic. I think this direction is very promising. If you are moving forward, many of those misalignment or inaccurate mimic of their human being, the digital twin, will keep improving their performance, reach a stage that there's no more question about whether I should use it or not, but rather like we must use it. Whoever not using it, they may be like out of the business by those people who are early adopters of this AI-driven workflow.
So now, as we are wrapping up, maybe connecting the dots, we see that the agents, the digital twins, are really good at, for example, if the human purchased the product, the agents as well. But like you mentioned, in some occasions, they're more submissive to the instructions.
Yes.
So they don't fully mimic the human behavior yet,
yes.
At least yet. So I'm curious, and I saw in your paper that you advocate for a hybrid approach where sometimes you use humans, sometimes you use agents as judges. Mm-hmm. What is your recommendation for teams? Where should they be inserting the human in the loop?
Exactly. So I think that's a great question. So my first of all, I should say my position is that these agentic AI systems or like a human digital twins will never be able to replace or substitute a human subject. I was trained as a human-computer interaction researcher. I'm very deeply rooted into the uniqueness of the human nature, right? What human can do, AI system can never do. However, in this kind of like online shopping scenarios, if you think about it, right, we can have a very high fidelity, like a human digital twin that can provide some preliminary results, feedback to the system designers and builders. These are trying to provide an answer to a very long-lasting kind of like a question or challenge that system designer and developer have been facing for the past 2-3 decades, right? You don't have an easy way to recruit a large amount of human subject to test your system and give you valuable feedback at reasonable cost. Till today, right, with the crowd workers, with the prolific help, you still don't have a good solution there. But I think earlier you hinted like, oh, what's the like non-AI workflow for these people? The non-AI workflow, right? Developers need to spend 2 to 4 weeks to develop some feature, right? And then the product manager or the UX researcher, UX designer need to spend another like 2 to 4 weeks to recruit participants, set up the study, and then have a dry run, maybe a dry run with 1 or 2 participants to make sure that you don't have a catastrophic study design problem. And then that's already 8 weeks later. You actually run the actual study, the online web testing or whatever, right? It takes another 3 to 4 weeks. After that, you write a report. Maybe the report will take you 1 week. So that's, to my best guess, 2 months to 3 months of timeline. With today's AI system, you can't afford that 2 months or 3 months of timeline as of with the human only workflow. With agentic AI, called coding, right? With this digital twin, subjects that to provide early feedback to your user study plan and study design, right? You can gather this feedback and finish a whole loop of this development and testing within maybe 3 days or 5 days maximum. That's the power. Once you have this you believe almost ready kind of features, you still want to test it with a human being, because after all, it's the human population, your human customer who are paying, right? Paying their attention, paying their money to subscribe to use your product. So I wouldn't say we're eliminating that, but rather we're already providing those human, maybe the version 100 of the feature, right? Then everyone is a win-win situation.
Yeah, at the end of the day, you need to ground the digital twin on a human.
Exactly. Yeah. Exactly.
Fantastic. This has been a really good conversation. I wish we had more time, and I'm sure it's the same case for our listeners. Yep. So the full paper is available on Archive. We're going to put it in the comments so you can check out the paper. And if you're building conversational agents or thinking about the next wave of human AI evolution, this is definitely worth the read. Dakuo, thank you so much for joining us,
thank
for
you so
sharing
much, Viviana.
Your wisdom with us. And thank you to all our listeners. Thank you for joining us live from HumanX. If you have enjoyed today's episode, please subscribe to the Frontier series. My name is Viviana Márquez, and I'll see you in the next episode. Thank you.
Thank you, and thank you all.